All right, welcome everybody. This is a special session. This is April 16th, 2025. This is the second installment of the SQL Server Truncated Icosahedron table. And with me today are two of the most amazing individuals in the SQL Server environment. I got Thomas Grohser and Brandon Leach. Um, Strap in, buckle up. We're going to be talking about availability groups today.
Mm.
So take whatever you thought about availability groups, throw it out the window. And we're starting at the 500 level and we'll go from there.
So, first question: do we finally reveal what the freaking title of that session is, or do
Yeah,
we keep this for the next one?
yeah, keep it a mystery. That's more fun.
Yeah, don't ruin the mystery this early in the series.
Let's do it this way. If someone, once we put that on YouTube, writes in the comment what that title actually means in regular human English, uh, then we might get some like interaction on YouTube later on. I guess. Okay, so no title reveal, so we're going straight into availability groups, and it's amazing how many variations of availability groups are out there.
Let me see. There's your standard availability groups. There's your basic availability group.
Yeah,
There are read scale availability groups.
yeah.
Um, there are there's also contained availability groups, and I'm missing one off the top of my head.
Distributed availability
There we
groups.
go. Yes, the one I hate.
Yeah. And some of them you can run clusterless and some with clusters.
Hmm.
And there's, I think it's impossible to have one session, regardless of the length, because at some point everybody would fall asleep, to actually discuss all the permutations that you can do. And I think that's one of the problems with it over time is that there's so many options that most people start choosing the wrong ones
Yep.
because it's either the ones they're used to for years or it's the one they just heard at the latest conference or the user group meeting for. But there's so much out there, and this is why we'll try to deep dive into the whole thing um, today a little bit. So as we did the first time, I have this little notes, which basically is just keywords that so we don't forget about individual options or so. But I have no pre-scripted content or anything else. Yeah? So that is things. Yeah? So the history of high availability with copies of your data. Last time we discussed high availability with moving your data. This time we duplicate the data to achieve the same thing. This has you have your primary database in some place, and then you make one or more copies of it in some other place. So if one fails, you still have the other ones, with the advantage that you have more than one copy of the data compared to a failover cluster. Um, but it comes at the price that you need the storage more than once. Yeah. But the good thing is that that storage can be much cheaper than the one you need for failover clustering. So in overall, the cost might be lower. Yeah. It always depends what your environment is and who's your favorite hardware vendor and all this stuff. But in the end, it is. I first noticed that there's a history how this all came together, and it's very quick. In SQL 1.0, there was backup restore. That's the only way you could get a copy of your data. In 6.0, two versions later, yes, Microsoft was counting very fast back then, but it gets faster. Uh, they introduced something called log shipping, where you took not just a backup restore, but then took every log backup and restored it automatically on the other side. Thing is, and that feature has not been improved or messed with ever since. The fun part is it still works great and it's still needed all the time. Yeah. And then in SQL 2005, so we went from 6 to 2005, so we increased the version by 1,999. Uh, they invented something called database mirroring, which is basically was log shipping in real time. So you don't write the file out, you send the data directly over. And then a couple versions later in 2012, they came up with always-on availability groups, which was basically mirroring on steroids, which allowed you to have up to 4 copies of your database, not just one. So you could have like a local HA and a remote DR copy, or even 2 remote DR copies with the same primary thing. People immediately complained that 4 copies is not enough. So in 2014, they increased that to a total of 8, which is still the limit today. Also in 2005, you could only have 1 synchronous replica. Starting with 2014, you can have 2. And then starting in 2019, you can now have 4 synchronous replicas and 8 in total. Any combination in between is possible. So you can have 3 async and 5 async or whatever. But total limit is still 8, but the synchronous limit is now 4. You can still only have 1 copy to do an automatic failover to. We will get to that later. Then in 2016, they introduced basic availability groups, basically an option only available in standard edition, not in enterprise edition. The first time that enterprise does not have a feature. And it allows you to do a 2-node AG, basically replacing database mirroring to get people off database mirroring. It's still there, but at some point they hopefully remove the code and save some disk space. In 2016, they also introduced distributed availability groups, which this is the hardest one to explain. It's basically you have 2 availability groups and you put an availability group across them.
It's an availability group of availability groups, kind of like that meme, Yo Dog, I heard you like blank, so I put blank in your blank.
Yeah. So that's the thing is. In 2017, in my opinion, the most important feature was added. You now have guaranteed commit availability groups, because believe it or not, up to this point in time, you could not guarantee 0 data loss with any of the high availability options in SQL Server. The problem is, while you have synchronous mirroring and synchronous availability groups, you do a transaction on the primary, it sends it over to the secondary. Once the secondary commits, it acknowledges that back to the primary, and the primary commits the transaction to the client. The problem with that is that works great if the primary dies. Then the transaction is guaranteed on the other side and you fail over and it's still there. The problem is if the secondary dies first, SQL Server by default waits 10 seconds. And if the secondary is still not there, it just continues on the primary without the secondary. So what people always forget when designing the high availability solutions is what happens if the DR side dies first? Then the primary keeps running, keeps producing new data, but you have no copy of it. And then if the primary dies then we have a big problem. And 2017 has this new option that requires a certain number of commits. So you can now set how many other nodes have to commit. And if you set that to at least the number 1, you can be sure that there's 1 machine out there that took the copy. So even if the secondary dies first and then the primary can't write anymore, the primary says, I'm done. Please fix your environment. I cannot continue. Problem with that is for that to efficiently work, you need at least 3 nodes, because otherwise, whichever node fails, the whole thing fails. With 3 nodes, you can have 1 that goes down and the whole thing continues. But that's a small price to pay if you have the actual 0 data loss requirement. But since 2017, that's finally possible. Also in 2017, they finally made it legal to have cross-database transactions in availability groups. Before that was technically always working, but not guaranteed to work. So what could happen if you have a failover while you have a cross-database transaction within the AG, you could fail over, and one of the databases would have the transaction and the other one would not. So it wasn't guaranteed. 2017, it's now guaranteed, and they guarantee also distributed transactions with availability groups to work under a long list of requirements that we can go through. 2017 also introduced the clusterless AGs, mainly because Linux didn't have Windows clustering on it, so they had to come up with something that works on Linux, and they decided it's either an external cluster or a clusterless AG, which is great. If you just need scale out, clusterless AG work great. If you need failover of any kind on Windows and you use clusterless AGs, you will be surprised how it doesn't work. Ask Brendan. He spent 7 nights fixing stuff after someone else had the brilliant idea to choose clusterless AG on a Windows cluster, which was the most hilarious thing is they actually had the cluster, but they choose.
Well, so the first example of that I saw was actually that they were trying to do what you used to do with people used to do with database mirroring, where they put a Windows Server failover cluster instance up. They'd have two of those, and then they'd use database mirroring to kind of semi-mimic what AGs are designed for. But they set up, two clusters, then they put a clusterless availability group on top of that. The problem you run into there is automatic failover is not possible. It's just not going to happen.
Yeah.
So
it just automatically fails over from one to the other node.
But that's it. If the whole cluster goes down, the clusterless AG will not fail over.
Yeah. Okay. SQL 2022 finally brought the last new feature in the availability group thing. It's called contained availability groups. Biggest drawback that people always complained about availability groups is that you have to create your SQL jobs and logins and certificates and everything on all the nodes. Yeah? And we all know human beings. We are really bad in repeated tasks unless it's a single task. But if you have to do 15 things on 3 nodes, there's a chance that on each one you forget at least one or two of them. So we often had the failovers, and then everything was great except the logins were not up to date or the permissions were not set on,
or the jobs.
Yeah. So contained availability groups, they are basically somehow messing with master and MSDB, and there's now multiples of them, and they in the background merge and join and do everything so that it looks like it's one. Honestly, I have not worked much with it because I'm capable of automating the stuff so that all the nodes look the same. So it came like, I would say 10 years too late. 10 years earlier, I would have jumped immediately on it. Today, my automation just allows me to just keep the nodes in sync. But contained availability groups, if you're a fresh starter and you don't have much of automation, that's a great place to make it simpler.
Yeah, I can actually at some point, I'd be happy to go through contained availability groups in depth and kind of point out why they may seem like they're a great option for you, but they might not be.
Yeah. What my biggest exploration was, and where I stopped like looking at it in more detail, was I couldn't find a single way to connect to the machines anymore to see everything. You need like to connect through 3 different ways to actually see everything, because certain things you only see on the instance and certain things you only see in the availability group because of this in the background moving around the data between the master databases and viewing it.
Connection context matters, and you're right. You have to connect multiple ways to get the full picture.
Yeah, so that is, but it's a start, and it's not a bad thing. Good. We already talked about. Yep.
There's another thing that was introduced with SQL Server 2022 related to availability groups that you didn't mention, and that was there were enhancements made to parallel redo, such as shared latches for redo. which makes things a lot more efficient.
Mhm.
And you're less likely to end up in a bad situation where your system is trying to go through the recovery process and parallel redo is blocking itself.
Yeah. Yeah, over time there were a lot of these in the background enhancements that you never see because they're not
Yep.
visible from the outside. They just do something in the background, like they completely, like when you compare the transport from the log data from the first version in 2012 to now, it's night and day how much they can put through the same amount of network compared to the beginning. But yes, the redo problem is an issue. So what happens is the transaction gets sent over, but not the actual result of the transaction. It's only what's in the transaction log file. So the secondaries have to replay, like when you restart SQL Server, whatever is in the transaction log. This makes shoveling the data over super efficient, but the secondary has to do all the right work the same way as the primary. With the one difference is it doesn't have the cache warming of the primary for all the reads, because the secondary never reads unless you use it as a readable secondary, but just for the redo part, it never reads the data. So whenever there's an update, there's a big chance that it has to go down to the disk and pull the data up and then start modifying, while the primary has everything in memory already. Yeah? And also, when the primary does something massively in parallel, on the secondary, there's two choices. You can either set it that it does everything one after the other, which then might take forever, or you set it do it also in parallel. The problem again is the timing on the secondary is different than on the primary. While in the primary it might have worked just fine, on the secondary, two updates might block each other for half an hour. And then continue. So there's always a nightmare scenario with the secondaries. So all the enhancement they did in 2022 with these ledgers and parallel redos and all that, I think it's very good. It's hard to actually see the benefits. What you probably will see is that you have less complaints that the secondaries are behind. Yeah, but you will never see a big "ooh, yeah, I'm faster" or something. It will just it's like the same thing as when you discuss Query Optimizer. Everybody complains about the three queries as Query Optimizer doesn't get right. Yeah, nobody ever talks about the 5 million queries it did perfectly. Yeah, it's the same thing here. Yeah. Yes. So the secondaries, which brings us to the next topic. Availability groups enabled you to have the secondaries readable if you want to. Yeah? It's a big price difference because if you make them readable, you have to license them. If
Yep.
you don't make them readable, they are to a
Well,
degree free.
to a degree, they're free as long as you have software assurance.
Yes, if you don't have software assurance, your CFO should be replaced with someone that can do basic math. But
Yes.
yes, if you don't upgrade, software assurance is cheaper over the years. Nah, it's yeah. So the readable, which allows you to actually have an almost infinite amount of reading capacity available. Yeah, because a regular AG can now make 8 copies if you need. So you can have 8 machines, and this could be really big machines that just do the reading traffic. And distributed AG allow you to be cascaded. So you can have like 106 readable secondaries if you do 3 layers of distributed AGs on top of each other. Yeah, I mean, I don't want to be the administrator for that environment, but um, there is technically no limit. You could add another
Yep.
layer, and then you would be probably in the 800 instances that would allow you to read your data. If you need that amount, you should reconsider what you're doing because you're doing something probably massively wrong. Um,
So
but
should we maybe talk a little bit about just kind of give a brief overview of each of these flavors of availability groups?
yeah, we should probably. Yeah.
right? Because we've talked about kind of standard availability groups. I you just touched a little bit on distributed availability groups, and maybe it's worthwhile. So, just so people are aware, your standard availability group is built on a cluster. That cluster handles the coordination around failover, but SQL Server itself, actually, the availability group initiates that. Your read scale availability groups, these are really designed for you just want to have a readable secondary, right? You're not going to fail over with a read scale availability group. It is typically going to be clusterless. Distributed availability groups, as mentioned, are an availability group of availability groups. These were designed originally for migrations. People try to use them for DR, but I would recommend against that. And I think TG, you would agree with me on that it's not the best
Yes.
idea.
So the problem with DR, we talked about this last time as well. Yeah? The problem with DR is people want to test the DR scenarios.
Yep.
Yeah. And while things like vMotion and log shipping or something are really great for a planned failover and then a planned failback afterwards, they might fail in the actual DR event. I'm not going to go into the discussion about this time, but there's a chance they might. But for distributed AGs, it's the other way around. Distributed AGs in an actual DR event work excellently. The problem is, in a planned DR event, there's about a 50-50 chance that while you fail over, your source, your old primary, becomes unusable. The reason for that is distributed AGs don't use clustering.
Yep.
And availability groups rely on Windows clustering to do the synchronization. So distributed AGs, by definition, cannot synchronize the two nodes that they fail over between. So what can happen is you're like, I'm a clever DBA. I'll stop all my jobs. I disable all the logins, so I'm the only user. There's nothing else running on that machine, and then I do the failover. You are correct. That enhances your chances. It doesn't guarantee you the win. It's like the lottery.
Yep.
Yeah? If you're the only player, you have a higher chance of winning. Doesn't mean you're gonna win.
And keep in mind too that it's not even like it's not even necessarily a user transaction that comes in. It could be a system level transaction. It could be the ghost cleanup process just kicks off or a checkpoint or something like that.
Yeah.
And
as
a
the sad
result,
part is, when you're not doing anything, the chances of ghost cleanup happening are actually going up.
Yes. So you could do everything correct and fail over, and all of a sudden you're rebuilding your source, restoring every single database to get it back in sync.
Again, the failover will always work, and you will not lose any data there because the ghost cleanup will run again on the other side. The problem is any kind of transaction on the source while you're doing the failover, and SQL has to destroy the original database. This is done because it was built for migrations, and the idea was always that the old one, you can never go back. It was never designed to allow you to fail in one direction and then fail into the other direction. Yeah. And therefore so using it for DR is a misuse of the feature. It was only it's used for one way forward. It was like, take whatever this availability group has and send it to the next one. Yeah.
No going back.
Yeah. One thing we haven't mentioned yet is we talked about cascading availability groups. That's not the worst thing you can come up with.
No, that does have a use case here and there.
No. It's like you need a lot of replicas. But if you don't need a lot of replicas, but you need a long line of replicas?
Yep. You want to force a specific route across the globe.
Yes. So the reason, and I have a practical thing, I cannot mention the company or what it was for, but the requirement was to get data from the middle of America, like a desert data center near an entertainment city, uh, to somewhere in Singapore. The problem is that's about best internet route you can buy for money was still 300 something milliseconds on latency. And with that, you only get a couple of megabytes per minute through because it takes forever to send the data. So we came up with the crazy idea to have a distributed AG from that data center to a data center in Los Angeles, from Los Angeles, a distributed AG to a data center in Washington State, Seattle area, from there to North Japan, from there to South Japan, and from there to Singapore. And with that, we got to a total of like 43 or something gigabytes per second that we could move instead of megabytes per second, which is basically a 1,000 times faster way of doing it. And the best way to explain it is before there was fire trucks, that's how people got the water from the pond to the burning house. They built a long line and each one was handing the bucket to the next one because overall the throughput of that line is faster than someone running back and forth all the time because you're eliminating the way back. Yeah.
Problem is,
yeah, you're eliminating the egg back on each and every packet. And that's another use. Again, that is still in production 5 or 6 years later now since we built it first. With a solution like this, it's absolutely paramount that you fully automate the whole thing because no human being will ever get that right.
If that thing ever breaks.
Oh, it breaks all the time. It just detects that it breaks and comes up again. Yeah.
But you have to do that repair process.
Yeah, and they know that, and it's part of the budget. Every log file, every backup is copied to every node so they can refresh the databases, and it's the cost of this thing is immense, but regulatory requirements, they need to have the data locally in that country, and they need to produce the report at a certain time, and the only way to make that possible is this insane chain. Once, if this cloud has one more node in the middle of Africa, they can actually cut down the number of hops by 2 by going the other way around the planet. Going from Vegas to New York to somewhere in Europe, Africa, and then to Singapore. But there's one data center is still not operational. So that's going to take a while. And it's unclear if it ever gets operational. So it's one of the, and this shows how flexible AGs are, but this also shows that you really have to talk to someone that knows all this stuff before planning your own scenario, because you will forget. I forget all this. Yeah. When I put together this list, I completely forgot contained availability groups. I put the list together. Luckily, I went through Books Online and checked my work, as you do, and I'm like, oh yeah, the contained availability groups. Good idea. Put that back in. Yeah, and you forgot the distributed AGs. Yeah, it's because it's not on your. There's so many options. It's not easily on your mind. Yeah,
and just to kind of come full circle, let me explain briefly just what a contained AG is. Most people, you can think of a contained availability group as essentially a virtual instance. It's an instance within an instance. It has its own special mini MSDB and master database. So the objects you stick in there, they travel with the primary. So if you create a login inside the contained AG and you fail over, that login is on that secondary. So it's effectively shared. The context problem, to give the TLDR, is in order to understand exactly who has access to what in a system, you would have to query each of the base instances in addition to querying into the system database of the contained AG. If you don't do all of that, you don't have the full picture. So it adds a lot of complication to enable you to not have to create all these logins individually on every system.
So if I interpret what you said correctly, you create a login within the contained availability group.
Yes.
Then you try to connect with that login to the actual node, to the instance. It will not connect you because the instance has no idea that that login exists.
Correct.
While when you create a login on the instance, it will work inside the availability group, but only on that instance, not on the other one.
And yep. And now think about this for jobs.
Oh, yeah.
So it gets even more complicated because with jobs, right? How are you going to monitor for failures?
Yeah.
Job failures, right? Because each contained AG has its own agent.
Yep.
It's a virtual agent running under the same account as the node itself. But if you go in there and you're looking for your backup jobs, well, you may not see them when you're looking at the base instance because you put them in the AG, which seems like the logical place. But if you connect to the contained AG, you won't see the base instances jobs either. So you can run into all sorts of conflicts and stuff if you're not careful.
Yep. I mean, this leads to one of the next topics to begin with. Connecting to availability groups to begin with is an adventure. Yeah. So let's try to get through that in a simple way. So if you do nothing, you just create your AG and you do nothing, you can connect to each instance and be happy there. And if there's a failure, your client needs to understand that it has to go to the other instance. This is how log shipping worked. It still works today. But Microsoft came up with an horribly brilliant idea of making it easier for you by complicating the whole thing to the maximum. So what they came up with is a concept of a listener. A listener is basically another door that gets you into SQL Server, but it gets you into the AG and not into SQL Server if you are on a contained availability group.
Well, so here's the thing. You actually can access the databases. They just won't show up in a list. Like if you query sys.databases, they won't show up. But if you use a three-part name, you can access node local.
So that's the next level. But on a regular AG, going through the listener or going directly to the instance is technically no difference. The only difference is if you fail over, you go through the listener, you can continue to work on the other side. If not, you have to. With an contained availability group, if you're not going in through the listener, you are basically shut out from most of, because the point is, if you access data, read or write it, go through the listener. Don't go any other way. If you manage the systems, you might or might not want to go through the listener or the instance. But if you're a user of a database, always go through the listener, because then your chances of being where you need to be are much higher than when you try it on your own. Yeah. So that was the simple part of the listener. First of all, you can have more than one listener. Why, I don't know, but technically you can. I think it's a good idea if you have multiple network cards or something like this and need multiple IP addresses and stuff like this. But I never came into an environment where that was actually used. But the problem is, we said you can have readable copies of your databases on the secondaries. So how you get to them? If you're not supposed to go to the nodes directly, but the listener points to the primary, how to get to the other side. And Microsoft came up, and that's the horrible part, with a concept of read-only routing. So you can basically say, this is my primary, and if this is the primary, these are the secondaries. So if someone says in their connection string, intend read only, I just want to read only, Microsoft redirects you to one of the other machines depending on what's in your routing configuration. Because to make things more complex, routing configuration can be load balanced across all the other nodes or just go to the first one available. Yeah, so that is the funny part here. The real tricky part of that is you have to construct this routing table for every possible combination for the primary. So it's not clever enough that when you fail over, it substitutes that node with the other node. No, it says, okay, now where's the read-only routing table for this other scenario? Which is not bad, because if you have like one primary and one readable replica in one data center, and then you have two standbys async copies in the other data center for DR, you want to keep the traffic in one, and when you fail over to the DR side, you want to keep it in the other data center. Again, getting read-only routing the way it should be is also an adventure. It works. If you do it correctly, it works. It's also funny that in some places you need to put in server names. In other places you need in put in IP addresses. All very interesting. And the last thing about connecting is, as someone who in his life had to do thousands of migrations from one system to the other, what I like to do is not actually let the client connect to the listener or even to the regular machine. What I do is for each and every database, I create a DNS entry and have that DNS entry point to the listener. So if for any reason I have to move this from one machine or from one availability group to another, all I have to do is change the DNS and not have to put in 6,000 tickets for the developers to change their connection strings, which might take months to get rolled out. Yeah. Problem with that is once you do that, you have to also create server principal names for each one of your DNS entries and not forget to recreate them every time they disappear. Problem with that method is there's a limit how many server principal network names you can have. You're going to ask me, what's the number? And I tell you, I can't tell you that because it's not a limit that has a number. It's a limit that has, there's only so many bytes available to store that in Active Directory. And once you exceeded the number of bytes, so the longer your SQL Server service account name is, the less server principal names you can have. The longer your DNS names are, the fewer thing is. Practically,
more groups that account is in,
yeah,
the less you have to work with.
Yeah,
it's the Kerberos token.
Yeah. So practically stick to about 200 to 300 server principal names per service account. Yeah, which brings me to each availability group, each cluster of availability groups should have its own service account.
Yep.
So you don't run out of. I've seen people that use all of production, one service account for all SQL servers. They run into this problem. Normally, you run into these problems somewhere between 800 and 1200 SPNs. I would limit it to 200, so you will never ever have a problem with it. But it's an important thing to think about. My tip here is each cluster that has how many nodes and runs how many availability groups, but they are all together on the same instances, they get one service account. It's a managed service account, a managed service account group, whatever it is, doesn't matter. They get one, and that's it. Yeah, and then
These
the next
days,
one is next.
sorry about that. These days I like to use GMSAs. So when I set up SQL Server initially, I will use a GMSA account so that the service account is auto rolling every 30 days or whatever InfoSec wants to set it to. And that also forces me to be unique within the AG. So like What'll happen is you'll create a GMSA, you'll create a corresponding AD group for that. You will assign permissions to that AD group, and you will also assign your nodes into that AD group, and you will give that AD group permission on the GMSA account itself.
Yep.
And this way, it's kind of hands off. Your SQL Server is more secure. And if you ever want to add a node slash replica, all you have to do at that point is add the computer account in AD to that Active Directory group, and you're good to go.
Yeah. No, that's a very good way of doing it these days. It took a while to get there because GMSAs were not working as well in the beginning, but they're doing now. So no more reason not to use them. Yeah, fully agree. Password auto rotation and all that thing. Also, that nobody actually knows the password is a brilliant thing, so nobody can accidentally expose it. Yeah.
It's also important, TJ, and I think you'll be able to explain this a little easier than I would. But it's important that when you install SQL Server, that's when you use the GMSA as opposed to going in and just taking your existing instances and changing them over.
Yeah. So there's a long. Technically, Microsoft supports changing the service account that SQL Server runs under. In production, I would never do that. It's one of the things that I just have a bad feeling about it because during setup, SQL Server creates so many certificates, so many entries in its own system tables, in underlying registry keys, and so on. I'm not 100% sure that when you change the name, the account name it runs under, that is all still valid, correct, and operational. Yeah, I mean, if you just change it, SQL looks to run fine. The problem is if you then use multi-hop Kerberos authentication or all these fancy things that you don't think about when you're doing setup next, you run into trouble. And then 6 months into the installation, it's too late to fix anything. Yeah. Because then you have to start from scratch again. So, yes, fresh install all the time. Put the GMSA in, Group Managed Service Account. I think that's the acronym for. Put that in, and you can forget about it. You want to change that thing, install a new one, and go on. Yeah, it's the same. I would never rename a server unless it's for lab purposes or something. Yeah. Can you rename a SQL Server instance or something? Yes. Are you sure that everything still works after you did it? I'm not. Yeah. But it's technically possible, but that doesn't mean you should do it. Yeah. Renaming stuff is dangerous.
Yes, yes, it is. I liken it to the same reason most DBAs don't like doing in-place upgrades,
Yeah.
right? You end up with all of these artifacts. You don't know if something's broken. Like you said, it may pop up 6 months from now.
Yeah.
It's just a big risk.
Yeah, and it while it's probably 2 or 3 or more hours of work to do a clean new install, it might save you weeks down the road.
Well, if you properly automated your installs, then it's
even better. Yeah. So, one thing we haven't touched yet is that availability groups, regular ones and contained ones, they work the same as regulars to that perspective. We're now ignoring everything that is distributed, clusterless, read-only, whatever. All these versions we ignore, we look at the same as they use Windows clustering to do the failover and coordination and failure detection, which is great because Windows clustering is around for almost 30 years, so it kind of works. The problem with it is it has probably the worst UI ever invented. So configuring it is not easy because the reason it's the worst UI is because it only exposes like half of the options you have. So the other half you have to set through PowerShell or some cluster XE program. Anyways, the bigger problem there is that while it relies on the Windows cluster to do the failover, that means the Windows cluster to do the failover needs to be configured correctly. And there's always in companies that who is responsible for the Windows clustering? Is it the team that gives you the server with the Windows install, or is it the DBA team? Yeah? You can get lucky that you have a cluster knowledgeable person in the Windows team, then you will be having a great experience. If the Windows team on the cluster just clicks next, next, next to every option and hands you over the machine, you might not have a cluster that is configured correctly to do all the failovers in all scenarios. Well, it works great when you right click and say failover, it will do the right thing. The problem is, will it do the same thing when there is some sort of an outage? Because for that, the cluster needs to be configured correctly. And this is where most AG installations fail. The SQL part is done completely correctly, but the underlying cluster part is ignored. The most important things is you have to get quorum right. Quorum in the cluster world means more than 50% of the nodes need to be able to see each other to run. That means for SQL Server and an AG to be available and operational, more than half of the machines need to be able to run. Let's start at the very beginning and say you have a 2-node AG. If one of them dies or fails, you no longer have more than half. You have exactly half, but you don't have more than half. And that means you will not be operational. So if you have a 2-node, you need one more to be operational. It doesn't have to be an actual node of SQL Server anymore. Like with database mirroring, you could use a witness, which was basically a developer, not developer, express edition of SQL Server that you put somewhere. It's fine. With Windows clustering, you can use a file share witness or any other quorum solution that is available in Windows clustering. Today, I would only use either file share witness if my environment is big enough, or use the Microsoft Cloud service to have a cloud witness. It's the cost of a cloud witness. It's like when you fail over a bunch of times a month, you finally reach like the 1 cent they charge you because of rounding up. But it barely exceeds 1 cent per month of cost, and that's worth the effort and not having to maintain the file share witness. It requires a rather complex setup on the network to get there, but that's a one-time thing to get right. File share witness is basically you have a file share somewhere, and both sides connect to that file share, and with that, that's the third vote that can figure out if one server fails, if the other two can still build a majority. When you have 3 nodes, it sounds easier because if one fails, the other 2 are still more than half. The problem with that is, how do you place 3 nodes? If all 3 nodes are in the same data center and the whole data center goes down, okay, the nodes are down. But if you put 2 of them in one data center and 1 of them in the other data center, and then the one data center goes down that has the 2 nodes, the other side is now less than half and will go down as well.
Yep.
So that's the conundrum with that. Yeah. The trick, and we spoke about this the last time, I'm quickly repeating it here, is Microsoft came up with this concept of dynamic quorum, which you get automatically without doing anything. If one of the 2 nodes dies first, and you still have a witness, you still have the 3 and they can nicely operate. Even if you don't have the witness, it's now 2, but then if one more fails, you have no chance. You still have the witness, it works. If the second one dies, first one died, second one died, with the witness again, you can now fail over to the other data center easily, because once the first died, the total number of nodes reduced itself to 2 plus witness from 4 plus witness. And that works pretty good. The problem is, again, if the whole data center dies in one go, like the network connection or whatever dies, dynamic quorum cannot reduce by 2, because now you have the 1 plus the witness on one side, and you have the other 2 of the other side, which is the perfect split brain. Are these
Yep.
2 still operational or not? So no, Windows cannot keep them operational because it's less than half. So they have to take down the 2. The other 2 don't know if these 2 are still there or not, so they have to go down as well. And with that, we discussed about that. The trick for that is that the primary node where you actually run your AG from in production, that's the one you have to manually remove the vote that this instance has. If you do that, you have a remote witness that is outside of your data centers, like a cloud witness or something, and you have one more node in this primary data center and one node in the other data center, regardless in which order they die, how many die at the same time, as long as you have 2 of them running, they will keep running. Yeah, and with 2, I mean the one in the DR data center plus the witness counts as 2. So if your primary data center dies, it's fine, because one node has 0 votes, the other one has a dynamic vote, DR has a dynamic vote, and the witness has a dynamic vote. The primary data center with the 2 dies, but that removes only 1 vote from the system, and the other 2 nodes still have each 1 node, meaning 2. 2 is more than 3, and you're good to go. The fun part is, if the one that has the active node dies and you have the one with the 0 nodes, you're still good because it's still running. As long as they all see each other, that will not make a difference. Again, if they both die, you fail over to the DR. If not, you stay there. It's complicated. I understand that. And as always, if you actually have a case where you need to implement this or so, you can email me at any time, and I will try to help and explain it. I have drawings. I have this in text form. And it was also when I do the homework for this session to actually like type up the whole session into a document. I will try to explain this as good as I can, so that you can do your scenario correct. But it's tricky. The nice thing is it works in each and every combination. You basically have to reduce each data center to 1 node, to 1 vote, and then you're fine. The ideal configuration is you have 3 nodes, you have 3 data center, you put 1 node in each one.
Yep.
And that just works. Problem is, convincing a company to have 3 data centers, not easy. But since today everybody's working in the cloud, putting the 3 nodes in 3 different regions, or at least in different availability zones or something, that is much easier. And then you have very little problems. Yeah.
So that brings up another interesting thing, because you're talking about, generally there's a good amount of distance between regions, whether that's in the cloud or between data centers here on the planet.
Yes.
The thing is that a lot of people don't realize that there are settings to around heartbeat communications that you may or may not want to consider tweaking based upon distance between sites. They come in 3 pairs. So each pair has a delay and a threshold setting. So you'll have same subnet, which generally I wouldn't touch. You would have cross subnet, so communication to different subnets within the and racks within the same data center, and then there's cross site as well. Generally, I leave those except for the last one alone, unless I have need. The risk is you can either be too aggressive with your heartbeat communication, and that can actually trigger a failover that what you didn't want. Or the opposite of that is you're too lax and you don't detect it in time.
Yep.
So it's a balancing act.
Mhm. Yep.
Any thoughts of yours around that?
No, excellent. I agree. Don't touch the local ones. Play around with the long distance. Rule of thumb that I use, I start by adding twice the ping delay between the sites.
Yeah.
Yep. Whatever is the current setting, I add twice, three times the ping delay. That should normally give it enough time to do that. The problem with heartbeats is you're they're measuring, does a heartbeat come back in a certain amount of time. So I'm like, I'm asking you, how are you? And then I look at my watch, and if you answer within 3 seconds, I know you're still alive. If you answer not, I call 911. Yeah, it's basically what a heartbeat does. The problem with that is if you are on the phone with someone else and they ask you, hey, how are you? You might not answer within 4 seconds.
Yeah.
And then I declare you dead while you're still alive. And we have a problem. And this is the exact same thing that happens with clustering. Yeah? If one node is so busy that you are running at 100% CPU, the heartbeat might not get answered in time, and it might cause a failover, which probably increases the workload and does
Yep.
the opposite of what you want. So you need to
Uh,
have it stable enough that a little bit of hiccup does not cause an failover. Yeah?
Yeah.
So I rather error out that an actual failure takes like 5 or 10 seconds to detect than that I'm so quick in the error detection that I have a thing is. And this is the part where I might have to touch the local ones as well if the systems are really busy. I've seen many cases where during the whole week there were never a problem. But then on the weekend, you run your maintenance, which runs over. So it runs into your DBCC check DB that runs over. So now they are both slower, and then they run both over into your taking a backup that is both compressed and encrypted. Yeah. And then you have like 600% CPU load on your CPUs, and then you're 90% done with that, and then the cluster says, I have no time to answer these stupid heartbeats anymore. I'm focusing on the workload, and then you fill over and you roll back all the work. Happened more than once. This is the part where you have to be careful, and might have been the requirement that before you do your maintenance, you amp up the numbers, and afterwards you put them back into something reasonable. Yeah.
Yeah.
One size fits all is great if it works. If you have extreme sizes of workloads, you might have to do it hard. And also, what you said before that you have the site configuration. That's one thing that you have to configure in your cluster configuration. Who is in which site? Because by default, the GUI won't let you do that, but the
yep.
PowerShell interface lets you do that. In both layers, it lets you define which site and in which cabinets you are. So you
Yep.
have your three fault domains. You can specify them, but unfortunately only through the PowerShell interface. No GUI available for that, but it's worth doing because you get much better results. If the
Yeah.
cluster is happy, your SQL AG on top will be way more happy.
Yeah, I'll
So
inject something here. When you're in an on-prem environment or even in the cloud and VMs are moving around frequently, I will sometimes actually desensitize the same subnet delay just a little bit. Default is 1 second. Sometimes I'll do to two, just because if a VM is moving around and it's got a big memory footprint or a lot of memory churn, any hypervisor out there will essentially smack the VM. It's called a stun, and it's like, slow down, slow down, slow down. Sometimes that is enough to cross that delay and actually trigger some kind of response from the failover cluster.
yep.
So most of the time, that 1 second same subnet delay, I'll actually bump it up to 2 seconds.
Yeah, if there's a possibility of say a vMotion for a cluster node, I would absolutely consider extending that, possibly even beyond 2 seconds.
I find 2 seconds is good enough for almost all circumstances. If you still get failovers because of that during a vMotion event or live migration or whatever hypervisor you're on and the buzzwords behind it, sometimes you can bump it up a little higher. 2 seconds is usually good enough.
in general, but it's really going to depend upon how active
Yeah.
the system is, right? What's the workload that's being run at that time?
Yeah.
I think we can give out the general advice that there's I cannot think of any reason to ever lower the numbers. Yeah.
No.
Yeah.
Agreed.
Uh, as long as you stick within the same like amount of digits, you can raise the number. So if you go from 1 second to 2 seconds, maybe 5, 6, 7, 8, 9, it's reasonable. If you go from 1 second to 600, no, you're in the wrong number of digits. Yeah. So stick with this. So if it's cross site, it's like 30 seconds. You can go to like 60, 90 seconds. Don't go to 500. Again, then rethink your plan. Yeah. So you can go up within the same number of digits, but you should never have a reason to go down unless you want to test failover and how many you can have per day. Yeah, that's the
Okay.
thing. And again, if you go higher there, the only problem is you have a few more seconds of outage. If you go
Well,
lower, you have many, many outages that are unnecessary.
yeah, and those outages can reach a point at which the resources in the cluster, such as your listener, just stop. They fail because there is a limit you can specify to X number of failovers within this amount of time is the maximum.
Yeah. So while we are at, we talked a lot about because it failed or things. So let's talk about what you have to consider when it comes to availability groups. Change the game over failover clustering a little bit because the biggest problem with failover clustering is that if a database fails,
Yeah.
the clustering has no idea that this happened and will just keep running. In availability groups, you have an option to actually have a failed database trigger a failover,
Yep.
which, as always, comes with good and bad news. So let's go through what can trigger failover. The typical things are power failure, network failure, storage failure, server host, the machine dies, the operating system crashes. All that is a clean failure and will trigger a failover. Yeah, might take a second or two to detect, but once it's done, it will fail over. That's usually not a problem. Yeah, SQL Server failure. Yeah, most of them, if SQL crashes hard, it
Yeah, that'll
might.
trigger it.
What you have to understand when you in the default installation of SQL Server on a cluster, it will try to restart SQL Server twice before failing over, because a failover is always a lot of things have to happen. So it's usually faster to just restart because if you're honest, if something in SQL crashes, usually restarting it will just fix the problem, and you don't have to go to a different machine for it to fix it. Yeah, I mean it's the sad part that if your Windows doesn't work, reboot it and it will work. Yeah? And it's the same thing if your application doesn't work anymore, restart it and it will probably work just fine again. Yeah. So the default setting is that SQL will start. The cluster will try to restart SQL twice, and if it doesn't come up, then it will actually do the failover. So if you don't want that and you want failover immediately, you can reduce that to 0. I usually leave it at the default settings because, as I said, 99.99% of the cases, restarting the instance will just fix whatever you have, and then you stay where you are. There's no DNS changes. There's no applications that have to reconnect. I mean, they have to reconnect anyway when you restart, but they reconnect to the same place. Yeah. I guess. So, but with availability groups, you can set an option that is called DB underscore failover, and you can set that to on. And then you basically have a way, if a database goes offline, it will trigger a failover of the availability group, which is great. as long as you remember that this is the case when you do maintenance and you take a database offline. To turn that feature off before you do that maintenance.
You also might want to consider suspending data movement before you do.
Yes, but that's why I said, while it's great that when you have a database that for whatever reason gets corrupt, taken offline, it's a good idea, move to the other node. There's a chance it works over there. Yeah. Especially since you have the data twice. If it was actually a storage corruption or something, there will be a good copy on the other side. Yeah. So to have that option, it's actually good. And there is even a way to set a custom stored procedure that the cluster calls every time, where you, based on code that you write, can determine if you do a failover or not. Make that really efficient, because that is called a lot. And don't like summarize 20 DMVs and join them and something. No, this should be, yeah. This is, for example, the one I know many years ago, for a company that I worked for, I had to write the store procedure to ensure that you can write to a database. If you can't write to the database, we had to fail over, because writing was more important than reading in this case. Yeah. So I had to come up with a store procedure that inserted into a test table so many rows that a new extent allocation happened. So I had to insert 64 kilobytes of new data to ensure that actually there's enough. It's both, you can write to the log because the transaction will still happen, and there's enough free space inside the database. And the fastest way to do that was not to go through 3,000 DMVs to see if everything worked. It was to actually insert the 64 kilobyte blob into a table every time that happened and create it. And then every couple of minutes you truncate that thing and start over again, so that you had a space allocation happening. If it worked, great, fail over. If not, you knew the database was full, and it caused a failover. And I think it was defined so that when they failed over to the other side on startup, they just truncated every table or something. It was a very weird database. It's not the normal thing, but with availability groups and that DB failover option, you can actually do that. And that is great if you need it. Don't touch it, don't play with it unless you have a reason. Yeah, the default ways of figuring out to fail over or not are good enough. And I rather have like once a year a case where it doesn't automatically fail over and the DBA has to right click and say fail over. Yep. Instead of I'm creating a store procedure and then I fail over 50 times a year for no reason because someone thought it's a good idea. Yeah.
I mean, in development, if you want to keep your developers on their toes. Mm-hmm. Sure, proper retry logic.
Good. So, going through my notes here, unless anybody else has something to what we already discussed more.
I think you covered that pretty well.
The next hint on my cheat sheet is the word. It's a single word, but could lead to at least an hour rant immediately. It's called patching.
Here we go.
So, problem with patching and availability groups. You have to do it in the right order.
Yep, and what that order is can change based on the roles of the replicas.
Yes, so it's not as bad as with replication. Replication, the order really matters because it might stop working. I mean, it's working horribly to begin with, but it might stop completely working if you patch in the wrong order. But for AGs, it's the same thing. Yeah, there is no right way of doing it. There's multiple ways of doing it, which one of them could be the one that works best for your company. But there's no universal way of doing it in a certain order, because you can prioritize one of two things. One is you have the least amount of outages during patching. That's the one priority, which is great. And the other one is you have the best possible way of rolling back if it doesn't work.
Yep.
The problem is, and we've all been there, and Microsoft has released hundreds of patches, if not thousands of patches for SQL Server over the years. And we all remember some of them. And we don't remember them because they were so great. We remember them because they caused us days and days of no sleeping. Yeah. SQL 19, Service Pack 9 is my favorite. How many thousand memory dumps did we have like every hour after applying this thing? So the problem is the easiest way of patching. Let's start with the easiest one. Yeah, you take everything offline. You off every instance that the database runs on. You patch them all. You bring them all online. They work. It's great. If not, you undo the patches and you bring them online, and it's still great. Yeah, horrible way of doing the patching,
Yep.
but it most likely will succeed. The other way is that you start at the replicas that you are not using, like a pure DR replica. You patch that one and you see if it works. Yeah. The problem is you don't actually know if it works. You know that SQL still works, and a passive replica that doesn't do anything still works, but you don't know if your workload will run on it. And this is where the difference between I have an easy failback or I have a minimum outage. Because if I know that my current primary node runs. So my approach is usually I patch the nodes that I'm not using. Then I'm patching my primary HA node. Then I fail over to the primary HA node. If everything runs, I keep running there. So I have only one failover to do that. If it doesn't work for any reason, I can still fail back to the node I know it was working on. If not, I'll patch that node, and then everything is patched. I did the one, so DR first, HA second, and then run in. Yeah. The problem with that is if I patch it this way, and then my primary data center fails, and I do DR on the DR side, I do DR on an untested environment that I just patched, and I have no idea if it's going to work or not. Chances are it's going to work. Yeah. But it's a risk. Yeah. So another way would be, okay, I patch the AJ node first. So I have the DR still on a known environment that I know it works, and I have the primary there. Then I fail over, then I test if it works. And yes, if I die within that, I fail back to an environment I still know it works. Yeah. With that, I have more than one outage most likely, because then I patch the other ones. I might want to fail back or something. So patching is an art. It's not a science. You have to figure it out what works for you. If you have 4, 5, 6 nodes, it gets even more complicated because you have to make choices in which order. There is always a way to do it, but think about it. If you just blindly like patch all the nodes in one data center, you will have massive amount of failovers.
Oh
Yeah.
yeah.
That
And
is
problems. What I see a lot of is, and this is true of both Windows, OS level patches, and SQL Server patches. When these things are pushed out through, say, something like SCCM or cluster aware updating, what they do is they simply apply, reboot, and they're relying on the reboots to trigger the failover. And the order of the nodes is kind of chosen at random, which is 99% of the time that is not an
yeah,
optimal and is risky to
yeah,
do. So as DBAs, I feel we really do need to kind of define that patching order, whether it's either of the methodologies you just described, which I use the last one myself, by the way. I think you know that. What I actually do is I create a table in a central configuration management database that for every cluster I have and every node within those clusters, I define a patching order there, right? So in that patching order, so there'll be a row. The key is every is cluster, replica,
Right.
and then an order number to say in what order it's in. Is it a failover point? I.e., do I fail over before I patch this? And then a target of where to fail over to. And I have to keep that up to date, but I always then know that my scripts and stuff that are going to do this patching, they're going to do the right thing.
Yep. It's basically the order defines, is it a requirement that at the end of patching you run on the same node as the beginning of patching? That's one requirement, because the applications cannot figure out how to connect somewhere else, which again should not be
It's
an
silly,
issue.
but is the case in some places.
Yeah, and especially jobs and other things might be only running on that one node. Or do you want to have the least amount of downtime by only failing over once? Yeah, that's basically the first choice you have to make. Yeah, and based on that, you can define this is the order. And yes, if they patch it, it will trigger a failover. You might want to fail it over manually before, because that might be a much cleaner thing. And as you said, when you script that out, it's easily possible. You know, they're going to apply them at 8 a.m. So at, I don't know, 7:45, you do a manual failover and then let them go wild with the patching. And when they're done, you fail back or move on to
What
the
I
next.
actually do is they call a PowerShell script that gets them the patching order. I give them the directions. This is the current primary, so this is the order in which you need to patch. Here's where you need to initiate the failover, and they follow that process.
No, it's again, it's a tough topic, but it needs. My favorite solution is to not patch.
Net new.
No, stop there. I'm not saying you should run on outdated software. Yeah, there's a difference. My
I
solution is
wasn't suggesting that. I was saying a whole new
I would
install.
rather not waste my life on automating patching. What I would do is I would automate migrations of databases.
Mm-hmm.
And instead of patching, especially in a virtual world where you have VMs, fire up new VMs, migrate to the new VMs that are already patched to the latest level, and then shut down the old ones.
Yep.
It removes the problem of, hey, I have no environment where I don't run, because I still have the old one. I can keep it around for a couple of hours. And I do it one machine after the other. I don't need all the resources twice. That is and you have always clean new machines with no surprises on them. Because what I find extremely entertaining is that almost every DBA is fine with patching a SQL instance, but they're absolutely against an in-place upgrade. Which, when you look at what patching does, it's an in-place upgrade.
It is.
It just updates a little bit less than a whole version upgrade. People are still thinking that SQL 2019 and 2022 are different products. No, it's the same product. It's the same. It's if you have SQL 19 with Service Pack, I don't know where we are, 57 or something, cumulative update, wherever they are right now in the 19 range, yeah, and you go to 22, there's not much code difference. This is little. You can be sure that a lot of the code that comes in the next version is already in there. It's just not enabled. Yeah. I mean, Microsoft's using the same binary. If you look what's already working in the cloud, SQL v Next is available there. Yeah. and they use the exact same source code to build the latest CU for SQL 2022. Yeah, so there is not that much difference. Thing is, so for me, patching is the same as an in-place upgrade, and I don't like to do that. So having the approach of I install a new one, thing is, and I can do this node by node. I don't have to do all. If I have a 3-node AG, I don't have to do all 3 nodes at the same time and move it to a new AG. What I could do is just add a 4th node that is already patched, remove one, add another one, remove one, add another
Yep.
one, and remove the original one. Yeah. So there's many ways of doing this, and we have to rethink because AFL patching on a running system can take a long time because if they are upgrading the database or so in any form, or if they have to change some metadata or anything during the upgrade, this might take a while. And yeah, so that's the horror of patching. It's always interesting. You never know how the night goes.
There's an interesting thing you can do as well when you're doing that, so that you don't have to actually reseed the databases necessarily. And that is, if you create dummy databases with the exact same structure, but
Mhm.
none of the data, what you can do is then you can deallocate those volumes, attach the volumes from your source system with those databases. As long as all the files and everything and their locations match up, boom, you just transferred over your 50 terabyte database in
Yeah.
a couple seconds.
Mhm. If anybody needs that code, email me because I have the one that creates the skeleton files.
Yep, same
Uh,
here.
in Does yours take into account if a file was deleted along the way and you have a gap in the file IDs?
It does have validation checks, yes.
Yeah, because the file IDs must also match.
Yes,
So
everything has to
yeah,
match.
so you basically have to create the file. You have to create also the gap files that are no longer there, and then delete them
Yep.
before you create the whole thing. Because otherwise, same goes for file groups. So if you had a file group and you don't have it anymore, for the rest of you want to do this, you have to create that file group. It doesn't have to have the right name, but it has to be in the right order. So if you see file group ID 7 and then 29 is the next one, you know you're going to have 22 dummy ones that you have to create and then delete. It's stupid, but it's how the trick works. Yeah. So again, if someone needs that, don't waste a month of your life to get it right. Uh, email us.
Email us, yeah, we'll hook you up.
There's no way to reinvent that wheel. Yeah, there's better wheels to work on. This one is invented and done.
I mean, honestly, at the end of the day, you're going to end up with almost the same code we have already. It's just your code isn't going to have all the trial and error you and I put into our scripts. So,
Oh, I took it over from Joe. You
okay.
know what I'm talking
Yeah,
about.
I know.
Yeah, and he figured all that out the hard way.
I
Uh,
figured it out the hard way on my end because I
well,
don't talk to Joe as much as you do.
a side tangent here. If you are on-prem and your system administrators think that they can take a snapshot of a virtual machine prior to patching and then roll the thing back if a patch has a problem, be extremely careful with availability groups because you got cluster metadata, you got databases that may be not in sync anymore, and quite probably you're going to introduce more problems than you're going to solve. So you have
So
to you have to really educate the systems folks to say snapshots might be doable, not here.
I would highly advise that sysadmin reach out to someone like yourself, David, someone who understands the implications of snapshots and SQL Server in depth, because there have been a lot of sysadmins that think that snapshots are backups. And then what happens is you go to restore that snapshot and all your databases are corrupt. Everything in your transaction log is lost.
Every time I find a sysadmin that thinks snapshots are backups, I reach for a wiffle bat because it's going to
I
sting, but it's not going to break anything unless you hit really hard.
I create a dummy database, load it up with a lot of transactions, and make them hit the button. And then they can explain to people why it didn't work.
Yep.
Yeah, no, it's the only way snapshots work if you have more than one disk involved, one volume. In
Yep.
if you're in a virtual world, you have virtual drives, and the only way it works if you have more than one drive per SQL server, and if you have an AG, you have three SQL servers, so you have at least three volumes. Yeah.
Yep.
And they need to be in something that the storage people call a protection group,
Yep.
which basically makes them one drive. So every write on these volumes, three or more, happens in the exact same order as SQL initiates them. There's no optimizations, there's no over going faster here than here. The problem with that is if you have an AG and it spans more than one data center, you are in two different storage arrays. And I'm not aware of any vendor that can do a protection group across storage arrays.
I don't think I don't think the technology
I mean,
available.
I'm not even talk about the performance of that thing, yeah, because that would probably write with like a megabyte per hour or something. Uh, but okay, for a patching process, that would probably be acceptable to put it in the protection group, take the snapshot, take it out of the protection group, do your patching. If it doesn't work, go back to the snapshot. That could work. But
Yeah.
again, cross data centers, I don't see that happening. If you're within a data center, that might save you or get you to the finish line. But again, it's a thing. Even if you have one SQL server with multiple volumes and they're not in a protection group, if you take any kind of snapshots or something, you have no idea if this is going to work or not. It's based on luck, not on technology.
Well, chances are, I mean, even if you could restore that database from a snapshot and it came up fine, um, it wouldn't work in an availability group because it would be out of sync right
You
then
have
and
to
there.
snapshot all of them as one unit. It's like
Yep.
you have to treat the whole availability group as one instance
Yeah.
for that purpose of the snapshot of rolling back to the snapshot. And again, this is I don't know, snapshots as backups is not. I've recently read a book, and in that book, the guy explains it really good. Snapshots are not backups. Snapshots are convenience copies of your data.
Yep.
Yeah.
That's
And you
perfect.
can do great things with them, like loading lower environments, stuff like this. It's all great, but they do not protect you from actual failure. Yeah, it's the convenience copy that can be very quickly done, and it's great, but it's not things on a regular application server that uses a couple of XML files for configuration. Snapshots work just fine. Yeah, and you can have the really unlucky moment where you click save on your text editor right in the moment in the middle where they take the snapshot and you only have half the configuration file rewritten. But chances of that, you're probably in the same room as the guy that presses the button for the snapshot. So, but technically it's possible.
Yeah.
An ASCII file write is the same thing as a SQL Server block write. It happens in yeah. No, don't get me started. It's yes, snapshots are not backups. Period. Let's stick
Nope.
with that.
Never have been, never will be.
Yeah, and it doesn't matter how the storage vendor calls them. If they call them clones or snap clones
Yep.
or magic bullets or silver bullets or whatever, it doesn't matter. It's all the same. It's just a different
Well,
name.
their job is to lie to you to make sales,
Yeah,
right? And
it's
our
convenient.
job as DBAs is to be able to see through all the marketing.
Yeah.
They're dealing with, like you said, general applications. They're not generally looking at mission critical databases here.
Yeah. Okay. One thing that in my notes I've put in the wrong place, so we should go back to that topic. well, it's more an infrastructure topic than the backup was, the patching was already maintenance. Network between nodes in an AG. Everything that we said last month in failover cluster applies to AGs, the same thing. Yeah. The nice thing is the data is independent, so they can be far from each other. They work great in layer 2. They work great in layer 3. On-prem, I've never seen any issues unless network people try to implement stupid blocking of ports or something like this. But if you leave them reasonably open between the nodes, you should have success.
Well,
In
one thing I
the,
would say, TG, is there is a separation of concerns that comes in. Like, we need to be aware of certain things. We need to ensure that the network team is doing proper monitoring, that the sysadmins are doing proper monitoring. For example, I came across an issue where a cluster would not fail over a while back. And the reason for that was that the IPs for the interfaces, the network interfaces, and the corresponding IPs for the cluster were marked as different subnets. For example, it was a /23 on the interfaces, it was a /24 on the IPs within the cluster. And so that broke things, and it was a bit of a pain to track down. But that's just something that sysadmins and network should have been monitoring, not us.
it can easily happen, or they were the same at some point and then they changed something, but changed it only in one place and not in both places. Thing can happen. Thing is, the big warning is if you have software defined networks, which are everywhere in every cloud. You go into any cloud, you have a software defined network. There's no physical patch network. There's underneath there is, but whatever you see in the cloud and your VM that you get in the cloud or whatever, it's a software defined network. They are getting more and more popular on-prem as well because they make administering from the network team super easy, and the software is out there and it works great. Yeah, it has one problem: software-defined networks do not have an ARP table, an address resolution protocol, and clustering, and therefore AGs within the same subnet. So if you have two nodes in the same subnet, they rely on the ARP table of the clients and the switches to route the IP traffic to the final correct interface. So if you have software-defined network, you have to put each and every node in a different subnet. Because if they're in the same subnet, a failover will not redirect the traffic to the new node. And it will never do, because the cluster sends out an ARP update, but the software-defined switch says, I don't care. I don't know that. And ignores it. And therefore, you will not fail over. If you go into clouds like Microsoft Azure, when you look at and you get an instance, what they do is they have a software created load balancer in front of the AG that does the actual failover, because they, for exactly that reason, they have, when you're in the same subnet, you have to put that load balancer on top of it for it to work. Yeah? But that then creates a solution that only works in that cloud. If you have now the same thing in AWS, they make it happen with a different way. But it's something you have to be aware. The simple solution is put every node in a different subnet. In the cloud easy, put every node in a different availability zone and you're fine. Yeah, most regions now have between 3 and 6 availability zones that should give you enough places to stack your machines, and you have no failover problems. Yeah, it's just something you don't think about. On-prem, it works just fine. You do exactly the same, and it stops working just because of that. When you have multiple subnets, you have to be sure that your DNS supports dynamic changes. And I know we told the story last time, but it's so funny that you have to tell it this time again. If you have a great team that figures out that your DNS servers are stressed and they want to give you faster ones, so they install a bunch more, and instead of changing each and every machine's configuration, they put them behind the load balancer. A very bad idea for clustering. Because what's happened is, when clustering moves the IP address from one to the other for a service, it sends to the DNS a remove this entry, and then it sends an add the new entry. The problem is, if you have a load balancer, one of them goes to one DNS server and the other one goes to the other DNS server. And whichever one then processes the whole thing faster wins. So you might end up with two IP addresses for the same IP, for the same name, or with none, depending in which order you process the whole thing.
So here's the scary part, PJ. Because people are probably thinking right now that, this isn't uncommon, but I have sysadmins telling me and network admins telling me that their vendors are telling them to do exactly this, to put DNS behind load balancers.
Yeah. For reading, it works just fine. The problem is there's very few applications out there that actually write to DNS.
Yes.
Yeah.
But clustering is one of those.
Yeah. And the fix is easy. Just pick any two actual DNS servers, put the two in the network configuration, and you're fine. But if you have no idea that someone did that and you wonder why randomly failovers don't work, sometimes it works. It really depends in which order the DNS servers process.
It will eventually
synchronize each other.
Yeah,
it'll eventually. And then they synchronize, and then it stops working. Yeah,
yep.
It's hilarious. But yeah, it can happen. So that's the network part. It's always fun to remember that week, month.
It was more like 3 months as we were trying to track this down.
I'd never thought that someone would do that. Good. So the next one is, I think I'm going to start the biggest controversy we ever had on this new thing here.
Okay, hold that thought. Whenever TG says that, for everybody on this call or watching this afterwards, if you're watching this after the fact, pause. Go get some popcorn. This is going to be good.
Yeah, it's probably overstated, but so now I have to come up with something really good. No, I'm sticking with the topic. So in my life, I came across a lot of DBAs that really like to do one thing on the weekend. Change the database recovery model to simple before running the index rebuilds. And they keep doing it in availability groups because they claim they are actually faster. And yeah, opinions?
Not a good thing.
Yeah, what they do is they basically take the primary database out of the availability group, change it to simple mode, do all the index maintenance, and then put it back into full recovery, take a full backup, reseed all the nodes, and put it back in the AG. Yeah. First of all, why are you doing massive index rebuilds? Fix your data model so you don't have to do index rebuilds.
I mean, you shouldn't generally have to anyways. I mean, most people are on SSD at this point.
Yeah. It's
all access is random anyway, so what's the point of an index rebuild?
Some people do it for saving space, because when they rebuild the index, all the gaps get removed, and then they do page splits all week long to make the gaps happen again, and then they rebuild it again to make it small. And
so it's an accordion that serves no purpose.
Yeah. Thing is, to give you an idea, I worked for the world's largest online gambling company, and they are still the largest. And on their primary database, they create about 17 terabytes of new data every day. And the last index rebuild was Easter 2005. So 20 years ago. In 20 years, they have not rebuilt a single index, and they're running just fine.
Yep.
The data model is designed to not create massive gaps.
But
And
that's the key.
that's the
That
key.
was intentionally designed as such, not the 99.99999 percentile of third-party vended software where they just don't care.
Yeah,
That's the difference.
that's different. The problem is, but it's only a space difference. It only costs you storage and memory. The fun part is storage and memory are the two free things on SQL Server. I mean, they still cost money, but compared to CPUs, they cost nothing.
Yep.
So what do people do? They fix the two free things by using the one thing they have to pay a lot for, which is CPU and licensing. Yeah.
Yeah.
So if you have to do rebuilds through an AG of indexes, the trick is very simple. The reason why you create this massive backup that you feel slows everything down, which theoretically probably doesn't, it's one of the things. If you watch something for an hour, if you watch a clock for 1 hour, it feels like it takes 10 hours. Yeah. If you just do something else and come back in an hour and an hour has passed, it doesn't feel like an hour. It's the same thing watching this here. Yeah. So the reason why these big backlogs in AGs happen is because a transaction is only transported through the AG transport once it's ready to go. So if you do an index rebuild, the primary will do the index rebuild. Once it's done, it sends it over to the secondary, and then the secondary will do the index rebuild. On a small table, that makes no difference. 5 seconds here, 5 seconds there, you're good. On a large table where the index rebuild takes an hour, it takes an hour on the primary, it takes an hour on the secondary. Yeah? The transport in between should be very fast. That's not the problem. It's the waiting and the bloating up of the log. The problem is if you bloat up the log, they can't do any of the other transactions happening at the same time. So the trick is you have big tables, partition them, and do the index rebuilds partition by partition, and all the problems will go away.
Yes.
I mean, it's not that simple, but think about, can you build a data model or a way of handling your data that you don't have to rebuild the indexes all the time? Because again, playing the accordion every week makes no sense. It wastes your resources during the week by expanding the database and then contracting it again. Yeah, I will not know it right now, top of my heart. A couple of years ago, I saw one of the best presentations ever. Someone actually proved that rebuilding indexes makes the system overall slower. And it's just the time. Index rebuilds made sense when data was stored sequentially and
Yep.
only could be accessed sequentially. We're talking tape time. The problem is with hard drives, it became more random, but you could still read from a hard drive faster when you read it revolution by revolution instead of moving the arm around. So that's why people still advocated for things. The problem is nobody should put a database file on a hard drive anymore. You put
Yes.
that on an SSD. There's no more reason. SSDs are much more reliable. They are now the fifth, sixth generation of drives. All the bugs are fixed. They are removed. The right wear level thing that SSDs wear out over time, that's fully under control. I haven't seen an SSD die from wear level in whatever. If you buy used SSDs that were used for 5 years, the wear level is at like 10%, so you still have 90% life left. Yeah, after 5 years, it's not as bad. Yes, if you do nothing else than write on an SSD from morning to evening, it will level out at some point. Yeah, but a database doesn't do that. SQL Server writes very little to databases, even if you do massive changes of data.
So
Uh,
from so from my experience, the reason people often do index rebuilds when they don't need to is because they see a performance benefit. But the reason they see the performance benefit isn't actually from making things contiguous. It's the fact that when you do an index rebuild, it recalculates all the stats with a full scan.
Yes.
If you just do the full scan, and by the way, if you partitioned your tables properly, then you get what's called incremental stats,
Yeah.
which makes things even easier. You use less CPU, you use less resources. You'll get the exact same benefit.
Yeah. No, it's yeah. Most index rebuilds don't fix the problem. It's the implied update stats in the background that fixes the problem. But
Yes.
yeah, it had to be said. And if we say it another 1,000 times, maybe one person out there will pick it up and not do unnecessary index rebuilds of them. I get the reason. I have a very fragmented table and I want to rebuild it so that I take less space. That one I get. Yeah. Everything else these days, no, it's unnecessary. Yeah. Yes, okay. So that was not as much as a controversy as I thought. Uh,
I think people are
more than
starting to get the idea.
yeah. It took a while. The problem is we hammered for 50 years. We hammered into the head to put everything in sequence. Yeah,
Yep.
and
And
now we have
now
to
for the last
hammer
10,
that. Yeah, the nails are all in. No, you get them out.
I'll just say it. I've got a number of folks that have told me, "Oh, I don't touch indexes because we're on SSDs." It's like, what else do? You update stats. Oh no, like you still need to do that.
Yeah,
Yep.
yeah. And the funniest part is when you look at super low level, random reads from an SSD are actually faster than sequential ones. I laugh always when people are testing SSDs with sequential workloads. It's like, yeah, you're underperforming the drive. The thing could work faster because a clever SSD, and I'm talking about good SSDs, not the cheap ones that you buy for 1999 for a terabyte. Uh, if they have multiple chips on it where they store the data. They can read from each chip at the same time. So if you read at 6 different places, chances are you get to 6 different chips and you can return the data at the same time. If you write sequential, it's very likely that all the data is on the same chip and you get like a fifth of the performance possible.
So TG, I have a task for you. I want you to create a short stroke mechanism for SSDs.
You know, I've done it for regular hard
Oh,
drives.
I know. That's why I'm saying it. I think
Twice.
that would be hilarious to find a way to essentially randomize your SQL Server data on an SSD environment so that you can get better parallel performance.
The fun part is we do just nothing. Over time, by chance, it ends up like this.
Yeah.
It'll optimize itself.
Yeah. I know I've done the opposite, where I drove an storage array into insanity by basically what I did is they had a certain amount of cache,
Yep.
and I created a database that was like one megabyte larger than the cache they had,
Yeah.
and then I forced a read through the whole thing, including the last megabyte, which tossed the first megabyte out, and then I started reading again because they claimed that they can optimize the disk layout for us. And then I let that run over the whole weekend, and they had to shut down the array to get back to like reasonable state because it basically copied all data from every drive to every other drive all the time to try to figure out how to get it faster, which it couldn't do because it was just perfectly it could I eliminated the cache basically and made it read things because I first did it with a tool which was much more efficient because it was like a 4 kilobyte exe file that ruined the array. They claimed that's not real database workload, so I changed it to the database doing the same thing. But yeah,
For everybody on the call, TG is a very evil person, and I love every bit of
like
it.
we need to figure out where the limits are. And if a vendor says we don't have a limit, I say challenge accepted.
I mean, you remember what I did, David, at that VMware event back in 2015.
That was amazing.
Yeah, they said push the sand to its limits, and about half an hour later, they come over to me and they're like, "Yeah, can you stop what you're doing? Active Directory just corrupted."
Yeah, can happen.
Hey, give me a challenge. We're going to have fun with it. Very simple.
Yeah. Eddie Wirch and I got in a contest to see who could take things down first.
Took what, 30 minutes?
Yeah, there.
And I think 10 of that was coffee. So
Mhm. Good. So we have about 10 minutes before Brandon has to leave. So let's tap into the most important stuff while he's still here. Um, Multiple instances and availability groups. Yeah. You can run multiple instances of SQL Server on one instance, which might give you better performance than a single instance on large systems. That's thing. The fastest way to virtualize is multiple instances. The second fastest one is one big instance, multiple databases, and the slowest one is put a hypervisor on it and then put operating systems on top of that. Um, the the whole difference is we're talking about plus minus 3%. Yeah, so we're not talking about anything relevant. Your whatever you have threshold on top that should not be touched should be way less than these 3%. If you need that, uh, figure out something else to make it fast. But multiple instance, my problem with multiple instances and availability groups is that availability groups are not, when you create availability groups, they're not super consistent when you have to specify the machine name and when you have to specify the instance name. So you have a combination of the two, which, as long as it's automated, it works. Yeah, it works just fine. It's just, if a human being has to mess around with the connection, there's a very big chance that they're gonna mess it up. Yeah, because in some places you have to put the machine name, and in other places you have to put the instance name, which is machine/instance name. And also, the problem is if you have multiple instances and you use availability groups, you want to have different IP addresses for each of the listeners. But you also want to have different IP addresses for the different instances itself, because you want to have the ability to talk to each instance without specifying the instance name. And the only way you can do that is if they have an unique IP address, because otherwise, it's the instance name is basically the port number. Yeah, it's not a DNS, but something like a DNS entry for the port number. Yeah, it's this SQL internally looks it up and says, oh, this name is actually port not 1433 but 1729 or something. Yeah, and so multiple instances, dangerous place. It works, but unless you automate the whole setup and configuration process, I would not do it, because there's a big chance
I
you will.
generally recommend against it.
Yeah,
It's more just from the fact that it adds so much additional complexity.
yeah. The problem I have is it gets really hard to find small hardware.
Yep.
Yeah. I mean, yes, VMs is a solution. Don't get me wrong there, but there's people or companies that are against VMs, and so it's now hard. It's literally 32 cores or 64 cores is soon going to be the smallest machine you can build. Yeah.
Yeah.
And right now, there's still vendors that sell you 8-core CPUs, but they're going to be gone soon.
Well, yeah. I mean, when was the last time you saw a 4 or 2?
No, they're not sold anymore. I mean,
yeah, eight's the smallest, and it used to
eight
be
right now is
two,
the
then
smallest.
four, now eight.
Yeah.
Yeah, they're going the way of the dodo.
And that's going to increase your SQL Server licensing.
Yeah. And therefore, if you want to have separation of security, instances are an option, and they work with AGs. But again, it's a painful process to get them running. Yeah. If you can avoid it, or if you are willing to virtualize, go that route. If for whatever reason you insist on physical hardware, that's the thing is. The nice thing is that most reasons why people didn't want to virtualize are gone. All these limits that
Yeah.
VMs had are by now are gone. Yeah, there's a theoretical memory limit, and yes, there's a theoretical core limit, but they're also way beyond what you normally need that this is not an issue. 10 years ago, you had limits left and right, especially in the memory places. Yeah.
Yep.
So instead of if you need to split your machine, probably do it with VMware or whichever is your favorite hypervisor of the month.
Well, yeah, I mean, a lot of people are moving away from VMware right now just because
Yes.
of the whole thing with Broadcom and the increase in cost.
Yeah,
I'm so happy that currently I don't have to make a decision about hypervisors because I would not know what to do.
I could do another 4-hour presentation on that topic alone, and maybe we will at some point.
Volunteering for the session after the next one.
I think that would be a lot of fun, and that's one that will probably get certain accreditations of mine revoked. But you know what? I just don't care. Yeah, and just for the record, everybody, the whole physical versus virtual discussion at this point, I can count on exactly 2 fingers in the last 2 years how many of those conversations I've actually had. Virtualization is an unknown quantity. People are pretty comfortable with it. And now it's just a matter of what's the right tool for the job, not can it do this.
Yeah, no, it's getting better and better with every generation, and there's still some funky things happening, but that happens in every operating system. So
Yeah.
Speaking of operating system, we haven't touched one extreme topic yet: availability groups between Windows and Linux, which is I mean I get approached recently a lot about ransomware protection.
Mm-hmm.
Because people are getting more and more nervous about it because it happens more and more often. Yeah? So, and one of the things is I've never seen a ransomware that can deal with both Windows and Linux. Yeah, because theoretically it's possible. Yeah, I've seen and I'm working on a proof of concept of ransomware in T-SQL. That is awesome. It's actually not.
I want in on that. That sounds like fun.
It's actually not that hard, which is embarrassing, but it will only affect databases inside SQL Server, so I cannot go outside to the operating system. But within SQL Server, I can ransom hijack your machine very efficiently because there's a feature that's actually perfect for it. And it takes for like 1,000 databases, it takes like a minute. But let's not tell people how to do it here. We might get banned from YouTube.
Probably not.
So the reason the Linux and the SQL, the Windows and Linux thing is, I don't want to run half the time on Windows and half the time on Linux or something. I don't have that ambition or idea. My idea is I love to put in one extra async replica that runs on Linux.
Yeah.
Yeah.
So here's the thing, though. The only way to realistically do that I'm aware of is with a clusterless AG, right? Because when you're working with Linux, if you want it to have a cluster to be clustered, you need to use something like Pacemaker. And in the Windows world, you use Windows Server failover clustering. Those two aren't really compatible to my knowledge. It's one or the other. So you can have a clustered Linux availability group or a clustered Windows availability group. And if you want to kind of combine those, you have to have a clusterless availability group. But if you know something, I want to hear it.
Yeah, so I have 2 solutions for that. One is going really, really old school and just log ship to the Linux instance.
You can certainly do that.
It's not as on time or point in time as an AG would be, but for that case, it's probably good enough.
Yeah.
If the choice is I lose all my data or I lose everything except the last 15, 20 minutes to the ransomware, yeah, I think my boss will take everything except the last 20 minutes. Yeah. So that's one way. The
Can
other way,
can you do a distributed AG?
that's the second option.
Okay, cool.
Yeah. So you build your normal AG. It's
Yep.
totally fine. You sacrifice one of the nodes, so you need an extra Windows node to do it. That is the base for the AG, and then you send it over to the other side.
Yeah, because in both cases you don't have a cluster, so
Yes.
you're not.
No, you have
You're,
a cluster on the Windows side that is it's AG.
no, but
plus
what I'm
everything.
saying is like in both of your options, you're adding a clusterless layer on top of
Exactly.
the.
Yes. Yeah. And then on the Linux side, you do a one node cluster that AGs with it with nothing but in this, and you transport it over. You cannot read it on the Linux side at all ever, but you know it's there. It's just it's
This feels very Kraken-y to me.
It feels like it's a different kind of cluster.
yeah, but
Yeah.
it's the problem with ransomware is you have to the only 100% protection against ransomware is being disconnected. But that
Yes.
would require I print the transaction log out on paper and carry it over to the other data center and scan it in.
Yep.
That's not an option. Yeah, there's no printer fast enough to do that. Not that I've not tried. But the next closest thing is to use two as different things. I would use the Linux machine, completely different hardware. The operating system is different. The Unfortunately, SQL Server.exe is the same, but it's layered off enough for it to maybe succeed. Yeah, in case of an attack. I mean, an attack of ransomware against SQL Server databases can happen in two ways. One is you go in, the ransomware finds a way inside of SQL and scrambles the data by going through the tables. The second way is it finds a way to scramble the data files while they're on disk. The problem is if it scrambles the data files on disks, even if you pay the ransomware, you will not get back your data because it will cause corruption.
I can confirm that one 110%, everybody.
Yeah, because SQL will scramble it and SQL will write over it. So when it unscrambles it, it takes a perfectly correct page and mangles it. Yeah. So there's just no way. Yeah. And also because the only way they can do that is you cannot open a file from a SQL database that is in use from any other application while SQL Server has a grep on it. So they have to do it in a way that they undermine the operating system and undermine the file system. So they're not even trying to do it in a consistent way. Yeah. So basically, if they manage to scramble your databases, they're gone. There's no way back. Yeah?
Don't pay the ransom, kiddies.
Yeah, no, there's no point in paying the ransom for that. You paid for your file share or file server or something. The other problem is if they get to that place, they most likely also reach your backups. Because your backups are just one file share away. If they somehow manage to get into that SQL server, they have somehow the credentials to go there. That means they most likely also have the credentials to go to the backup share because the SQL server is usually allowed to write to the backup share, which means if they can get into this machine, they can get to
you should still have ideally a third location for your backup. So you take the backup from SQL Server to a location, and there should be some other process with a different set of credentials that copies it off site somewhere.
Yeah.
At least if you're doing it right.
Yeah. But again, it's a not trivial thing to protect against in all access vectors attack vectors, not access attack vectors that can happen. It's an annoying thing that is happening, but it's out there. They're happening every day because someone loves to click on attachments on emails. And I would not exclude myself from being at some day I might do that as well. Yeah.
Click the wrong thing.
Oh, yeah. I know once I worked in a company and they got me with one of their email test emails. Yeah. I was I was discussing with my bank some issues with my credit card, and another email came in with some credit card stuff in it, and I just like, what do they want from me now? And clicked on the link. And it was too late because that email was not from my bank. That email was from, in this case, luckily IT that sent it out to test. But it was supposed to be one of these thing tests. Yeah, it happened. It's nobody. Doesn't matter how careful you are, giving the right circumstances, you will make a mistake. And usually, in this case, I was like back and forth with my bank five times about something on the credit card, and then this other thing comes along and talks about credit card, and I'm like, what do they want to now? Click. Too late. Yeah. And in this case, it was just an invite to the next security training from the company, which was super boring, but
And suddenly mandatory.
yeah, no, for all the people that clicked on the link, it was mandatory. Yes.
That's effective.
Yeah. But again, I caught hundreds of these over time, but one I did not. And so ransomware will happen eventually, because if you have enough employees, the chances are someone clicks on it. It's just a numbers game. Good. Yeah. Yeah. The only thing left that I have is licensing for availability groups, which is an interesting topic by itself. The basic is use SQL 2019 or later. It's much cheaper.
Yes.
In 2019, the licensing changed for availability groups. Before that, before 2019, when you had software assurance, you could have one free DR or AJ copy. In 2019, you can have two plus one in the cloud when the cloud is from Microsoft. Which
Only Azure, not AWS or GCP or anything like that.
I'm so surprised that nobody actually like went to court to like somehow nullify that or in any form. I was like, okay, this is going to be there for 3 months and then some court will strike it down. But no, it's still valid. Thing is, the trick is you basically can have a 3-node AG for the price of one, as long as you don't make any of the nodes readable. Yeah.
Yep.
Microsoft normally allows you a tiny little DBA database to be readable on each node. They're not. Thing is, it's not official, but they're not gonna make you pay a license if there's a DBA database on it. Yeah. But if you have a good relationship with Microsoft, write it down somewhere, make them put a stamp on it, and you're fine. Yeah. It's not like it's within reason. Maybe at some future point they will exactly define how this goes. But you have to have a way to extend master database, and as long as they don't legally allow you to put something in master, and with legally I mean they stop supporting you if you do that, they have to give you a way to put your code there. And again, normally they are very. That's not a thing. It's not a reason why you end up on the front page of the Wall Street Journal as cheating company or something. Yeah, that's what I have from all the options of AGs. So if you're not confused at the beginning of the video, you should be confused by now. Then our job is done.
We touched on so many different areas.
And we went deep, but we just touched the surface. There's so many more.
Like each of those we could probably discuss for like hours.
Oh yeah. And some of them we have, at least in the small group, not in a public environment, but I know coming up with solutions what to do is. The important thing is define what you need, then look at the options, what's available. Don't engineer a solution and then write an SLA, because that normally doesn't work. Write the
SLA first.
Then design a solution. Then you might go back to your higher ups and say, okay, here's two options. $50,000 and we can do this, or 20 million and we can do that. You ask for the 20 million solution, but maybe we want to do the other one. And I pretty much can guarantee you they will go for the cheaper one. But
Always do.
It always goes back to the SLAs. Simple as that.
yeah, no, if all this high availability stuff, everything else, there's no point unless you know what you need. Uh, you can engineer to the end of the world. There's always a thing. It's
And
what's
keep
the compromise you and your company can live with. Yeah.
and
What
keep in mind too that your SLAs should be driven by the needs of the company, but also by the regulations you fall under,
yeah.
right? If you're under FINRA, FINRA requires certain things.
Yeah.
And so your SLAs should meet that. So if you want to make the case for the higher cost, the way you do that is you tie it directly to items in regulation that your
Yeah.
company is subject to.
Yeah. No, it's yesterday I spoke to a user group and my slide deck started with one very simple slide. It says, nobody cares if you can back up, only
Yep.
if you can restore. Yeah.
Yep.
Like, your bonus doesn't depend how many backups you took. Your bonus depends on how many times you restored the database and did not lose any data. Yeah. And that's it. And if you look at what you have and what your company has, and you look at it objectively, there's many cases where it's not critical. If you ask the person that works with that database every day, it's the most important one on the planet. But if
Yep.
you look at the whole company, that database might not be relevant at all. I have cases where there was a good case. I don't need a backup at all because we just get a new copy from the vendor. Why take thousands of backups of this database? If it fails, we just call the vendor and he sends a new one. Yeah. Happens all the time. If we get out of sync, they send a new one, so we have all the data again. Yeah. Or this is a staging area for a data warehouse. There's no point in making this highly available in an AG. You have an empty database on each one of the nodes with the schema that you need, and whichever node runs the load uses that staging database from scratch.
Yeah.
Yeah. I had a case where we were working on a recovery of a database that would have taken probably several weeks because it was like a 50 gigabyte database with a 600 terabyte log file. And the owner of the database says, yeah, just drop it and give me an empty one.
Yeah, 600 terabytes of logs. So that's going to be a lot of log files.
It was basically the changes of 3 to 4 weeks. So for 3 or 4 weeks, there was no log backup, and there was an open transaction for that long time, and it backed up. Thing is, so the fun part is all they do in this database is dump the data, delete it, dump, delete, dump, delete, dump,
Yep.
delete. And we had like 6 weeks of that, and they're like, yeah, we just give us an empty one, we dump, and we're good.
Yeah, I
And the
worked
same
with
goes, what I'm saying is, if we would have built an AG for this thing, yeah, there's no point. Yeah.
No.
And this is why you need to know what you actually need. Yeah. Should you run after each tiny little database? No. Yeah. But at least have something gold, silver, bronze, or something where you have like 3 general categories where you can put in. And the problem is that if you are in a company that doesn't do chargeback, everybody's going to pick gold for everything. Because why would I pick silver or bronze? The
Yep.
moment you have chargeback, everybody picks bronze unless they really have to not. Yeah. So while I think chargeback by definition is stupid because you're just moving the money from the left side pocket to the right side pocket, it helps people think about what they actually need.
Yeah, and you just got to be careful. I mean, quite literally last week, I'm on the phone with a client and one of their mega software vendors, shall remain nameless. This vendor was saying that 1,500 databases in one availability group was a good idea. After I had stabilized them by removing a ton of the pre-production and archive and reference databases all out of the availability groups to get them down to 600 databases, where we were able to stabilize it barely. And how many of these are critical? Nothing.
Mhm.
Half of the stuff is like a daily reference bit that gets updated by a script. Other
That's a
ones were
lot of,
last year's accounting copies of the databases. You don't need these in the AGs.
yeah, that's a lot of databases in a single AG.
Oh
Yeah.
yeah, no, it
Uh,
stood no chance.
I think the Microsoft recommendation is still 100, 10 AGs on in one cluster and 100 databases per AG. I think that's
yeah.
still the recommendation. It hasn't changed since the beginning. So I think 600 you might be fine. If you get into the thousands, yeah, I can see definitely problems.
No, 600, we kept it from crashing multiple times a week.
Yeah.
We are currently working on re-engineering that at the detriment of said vendor.
Mhm. Yeah. I once worked in a company where we reached the 32,000 limit on databases.
Ooh.
It was the virus scanner. And every 5 gigabytes, they created a new database. So they could run with Express Edition. It's not a bad thing. Normally, you just install it with Express Edition. They kick out 5 gigabyte databases, detach them, create a new one, and keep going. On Enterprise Edition, that worked a little bit different, and we ended up with, after a couple of weeks, we ended up with 32,000 databases on that machine, and had to learn how to get rid of them. It's not that easy.
You just reminded me, TG, of our pain and suffering that we endured at the hands of a vendor that made lighting for
Oh
buildings.
yeah.
And what it did, David, was it had a bug at one point, and it named all the databases after the full path and file name of the primary data file. So you would have database, you go to backup a database, and it would be like backup database C:// something slash primary file dot MDF to disk.
Yeah, which
And
doesn't work because it contains illegal characters for the file system. Yeah, no, I remember that. Yeah. And the fun part is, if these databases don't work, the lights literally went out.
I'm dealing with one right now. It's a, power usage collection mechanism for very large data center conglomerates. So what they do is every 12 hours, these collectors create a row in a database table. And then for the following 12 hours, every 5 seconds, they update the row and they append into one column every data point. And then at the end of 12 hours, it it cycles. So the availability group traffic in terms of network throughput is just like this odd sawtooth pattern every 12 hours where it goes from, kilobytes a second all the way up to a couple hundred megabytes a second. And then it dies down, it does it again. But when you have about 25,000 of these endpoints all pushing data like this every second of the day, that's a system where the unauthorized third-party custom integration into that database that likes to change data, yeah, you get one cascading block, it takes hours to clear. And when it's a 4-node availability group with a distributed AG on top of it for reporting.
beautiful.
Yeah, it's a fascinating setup.
Yeah, no, it's every time you reach the edge of what's possible, you can make it work, but it's ugly, and you should avoid it. And it's amazing how many times problems and limits can be avoided if you just have a look at the data model or the way things are done. Uh,
Oh, come on, man. Living on the edge is when you feel alive, you know?
Yes, it's fine till it becomes so problematic
I
that
know.
you are alive 24/7 because you can't sleep anymore.
Yep.
And
Yeah.
it's often I'm I was people ask me, or Microsoft, not people, Microsoft ask me all the time if multi-writer is a requirement for SQL Server. That in a distributed environment, multiple writers. I'm like, no, I have not seen any requirement ever in my life that I could not handle with a single writer. I've seen cases where I need multiple readers, yeah, and that's not a thing. But I've never seen a case multiple writers. If the writing became a problem, we had to look at the data, and then we figured out it's stupid to do it with a database. Yeah.
Yep.
The only places where you have writing issues is if people start inserting video files in blobs. Yeah. If you write every row is a couple of blobs with 2 GB each, yes, that is not efficient in a database, and you need more than one writer to handle that. But that should not be in a database. Yeah, these
Yes,
videos
that's
should
not
be
a
somewhere.
database problem.
Yeah, you should have like the link to that thing in the database or something. Yeah, great, but not that. And if you take like the biggest financial operations like credit card clearing or something, you can still capture all that data on a single server. It's not it you can do on a SQL Server modern machine. Yeah, and with modern machine I mean something that's $100,000 hardware. Yeah, you can capture easily 1 million uh, inserts per second in a financial transaction table. Yeah, with the same time 1 million updates to like an account table, something like this. Yeah, that's a lot. Yeah, even if you are a really big organization, to have 1 million financial transactions per second, no. Yes, does something like a stock exchange where millions and millions of people try to buy and sell at the same time, that's a different beast. Yeah. But even that, you don't need multi-writer because you can partition a stock exchange till it works again. Yeah. And worst case scenario, for each and every stock, you have your own machine. Yeah. And that's exactly what they do. And not just one machine, they have multiple machines. So if one fails, the next one takes over. And that's why they can't afford a test environment. Uh, no, on Friday night, that particular stock exchange, once the closing bell rings, they block the production accounts and put all the development accounts in, and the developers get the systems. And Sunday at 2 p.m. in the afternoon, they take the permissions for the developers away and restore Friday's backup.
Interesting.
If you have 40,000 servers, that's the only way you can do performance testing. Nobody buys you 40,000 servers in a test environment.
Ah, they're no fun.
So, but it's, yeah. If you're on call on Sunday and you get an email that the restores are not working, you call all your friends in there. Help me restore that thing because Monday morning at 9:30 or something, this or 8:30, this thing has to run again. It always does. The nice thing is that most of the databases on the start of the trading day are just empty. So they're not restoring actual like full databases, they're restoring skeleton databases because all day long they just collect the data and then they move it to other systems. But it's an interesting concept to have uh, to have your performance test environment being production on the weekend. Uh, why not?
Interesting.
It's an interesting
All
concept.
right, folks, I need to get going in a
Yeah,
minute.
Yeah.
awesome.
I,
Yeah, I mean, we're basically we're through the topic. We're just talking about
Yeah.
stuff.
yeah.
But
I'll do a quick wrap up here. I mean, just if you're still on this call, thank you. These are always deep topics. These are a lot of fun. These are the 500 level things where a lot of people see them as edge cases, but most of this is real world. It really is. You may have to stretch a little bit to make it real world, but this is pretty real stuff. So if you're watching this after the fact, as always, thank you. Don't hesitate to reach out if you have any topics you want us to discuss or even create presentations for. It's a lot of fun. And this is the second in what's hopefully going to be a really long series of these with TG, Brandon, and some other folks in the community.
Yeah.
So thank you. And we look forward to the next one.
Yeah. Goodbye.
Thank you, everyone.